Hi everyone, so here we are with section 3 of the 2017 CABE Integrated Math past paper. So let's go into it. They want to evaluate the limit as x approaches -2. Now if we plug -2 in this denominator, we'll get a 0. So this function is an indeterminate function. So what we'll do is factorize the numerator, and this is difference of squares. So this will give us an x plus 2 and an x minus 2. So the x plus 2 gets cancelled with the one below, and then we'll plug our input value of -2 in place of the x that's left. So -2 minus 2 gives us -4 as our limit. In this second question, you need to differentiate 2x plus 3 all raised to the power of 6. Now here we have a function raised to a power, so we'll use the power rule. So power times coefficient is 6, write back the bracket, subtract 1 from the power to get 5, and then if we differentiate inside this bracket, we'll get 2. So our simplified answer is 2 times 6, 12, and 2x plus 3 all raised to the power of 5. Here we have y equal e to the x sine x. We need to differentiate this function as well. Here we have two functions being multiplied, so we will use the product rule as you see here. The first function, e to the x, is our u, and the second function, sine x, is our v. So when you plug it in, u e to the x, when we differentiate v, we get cos x, plus v, which is sine x, and when we differentiate u, which is e to the x, we get back e to the x. We can leave it as this, or we can factor out what's common, which is e to the x, to be left with cos x plus sine x in bracket. In this question, they want us to find the stationary points of this function. Now another term for stationary points is turning point or critical point. And once we found those points, we need to state whether they are maximum or minimum. Now to find a stationary point, we equate the derivative to 0. So first we'll differentiate our function to get 3x squared minus 4x plus 1. And here we equated it to 0. Now we are going to solve this quadratic. 3 times 1 is 3, and we need factors that will give us a -4. So those will be a -3 and a -1, because when multiplied we get back our 3, and when added we get this -4 that we need. So now we have 3x squared minus 3x minus x plus 1. Factor out the 3x that's common to be left with x minus 1. Here, -1 is common, and we'll be left with the next x minus 1 in bracket. So now we have 3x minus 1 and x minus 1 equals 0, making our values of x +1 and +1/3. Now that we have our x values, we need to verify their nature. One way of doing so is via the second derivative. If the second derivative is less than 0 or negative, it is a minimum, and if it is greater than 0 or positive, it is my mistake. If the second derivative is greater than 0 or positive, it is a minimum, and if it is less than 0 or negative, it is a maximum point. Okay, so what we're going to first do is find that second derivative. We're going to go to our dy dx function and differentiate that. So when we do so, we get our second derivative to be 6x minus 4, as you see below. Now we're going to plug each x value one at a time. When x is equal to 1/3, 6 times 1/3 is 2, and 2 minus 4 is -2. So this point where x is 1/3 is a maximum. When x is equal to 1, 6 times 1 is 6, and 6 minus 4 is positive 2. So therefore, when x is 1, it is a minimum point. For this question, they want the partial derivative of z with respect to y. So you're going to, since it's with respect to y, we are going to differentiate the y components and the x's will be kept as constant. So if we differentiate a constant, we're going to get 0. So here, this x cubed is acting as a constant, which will give us 0. Our 4y squared will give us 8y when we differentiate, and if we differentiate ln y, we'll get 1 over y. So this is our answer, 8y plus 1 over y. In our next question, it says, a small business profit function in dollars for a given year is given by this function, where x is the number of cakes sold. They want us to estimate the number of cakes that must be sold to get the maximum profit. Now the key term here is maximum, which is referring to stationary point or critical point. So that's what we'll do. We'll differentiate our function and equate it to 0 and solve for x. So if we differentiate this, we'll get 150 minus 18 over 20 or 9 over 10x, and this will give us 0. So here is our derivative, which we will equate to 0, and solving for x, this 150 comes over as a negative 150, and this negative 9 over 10 that's been multiplied comes over and gets divided. So when we simplify that, we get 166.7, and therefore or x, or the number of cakes that must be sold to make maximum profit, is 166.7, which is roughly 167 cakes. For this question, we're integrating. So this is in the form integral of cos ax plus b. The rule is, if we integrate cos ax plus b, we'll get a positive 1 over a sine ax plus b. So therefore, integral of cos 5x minus 3 will be 1 over 5, because 5 here is the coefficient of x. So once more, 1 over 5 sine 5x minus 3, and our plus c goes at the end. For this question, it says to show that the integral from 1 to 3 of our function here is approximately 9.08. So this is definite integral. The rule is, we're going to integrate our function, and whatever answer we get, we're going to plug the upper limit, then the lower limit, and subtract the values. Now if we integrate x to the 5 over 2, we'll get 7 over 2, because we add 1 to 5 over 2 to get 7 over 2, and divide by 7 over 2, which is the same as multiplying by the reciprocal 2 over 7. When we integrate negative 2, we'll get a negative 2x. So here is our integral, in which we're going to plug our upper and lower limit. So first we plug our upper limit into the first bracket. So we're going to substitute our 3 wherever the x is, minus sign, and then the lower limit, which is 1, in the second bracket, substituted in place of the x. Now, if I find 3 raised to 7, is it? Yes, 7 over 2, and now multiply that answer by the 2 over 7 that we have, we get 13.36, and 2 times 3 is 6, so this is for the upper bracket. Now for the lower limit, 1 raised to anything is 1, so this is a 2 over 7 minus 2, which is negative 12 over 7. Let's see, 2 over 7 minus 2  2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 minus 2 is a negative 12 over 7. So 2 over 7 This upper bracket calculated is 7.36. Minus sign goes back, and this negative 12 over 7, which in decimal form is negative 1.71. The two negative signs together makes it a positive, and when added, we get 9.07, which is in fact approximately 9.08. In this question it says, a radioactive substance decays at a rate of dr dt equal negative kr, where t is the time and k is a constant. They want us to show that r of t is equal to e raised to negative kt plus c. Now this is differential equation. Here is our differential equation that we are working with, and the rule is to solve it, we will first separate the variables and then integrate both sides. So when we separate our variables, we are grouping. So all the r's will be on one side and the t's on the other. This r that's been multiplied will be brought over as 1 over r, gets multiplied by the dr, and this dt will go up and get multiplied by this negative k. Now that our variables have been grouped, we're going to integrate each side. Now the integral of 1 over r is going to give us a ln r, and the integral of negative k with respect to t will give us negative kt plus c. Now for us to mimic the equation, we have to raise each side from e. Now e to the ln r will give us r, and now this side is now raised to the t. So here we have our function that we're working towards, r equal e raised to negative kt plus c. In the second part of the question it says, if at time t equals 0, the substance has an original mass of 500 milligram, show that r of t is equal to 500 e to the kt. So it's saying that when t is 0, r is equal to 500, and we're simply going to plug that into the solution that we have. So r is 500, and we now have e to the e raised to negative kt plus c. I separated this and make it e raised to negative kt times e to the c, because the rule is when we multiply we add our powers, so this will be the same thing. Now since t is 0, I substituted the 0 in place of the t, and now this becomes e raised to the 0. Now anything raised to a power of 0 is 1, so all that we're left with now is e to the c equals 500. So now we can plug the value of e to the c, because once more the function was separated to give us r equals e raised to negative kt times e to the c. So now r equals e raised to the negative kt times e to the c, which we found to be 500, and it does, and it is similar to what we were finding. For this last question it says to find the area bounded by the function. You see here the x-axis and the line x equals c, and it says c is the critical value of f of x, which corresponds to the maximum point. State the answer to 3 decimal places. So we need the area of the shaded region. So it's from 0 to c. So first we need to find c, and it says that c is the maximum point. Now maximum point means is a stationary point, and to find a stationary point we will equate the derivative to 0. So if we differentiate this function, we will get 4x squared minus 15x plus 10, and now we will equate it to 0. Now if we look at our derivative, 4 times 10 is 40, and there are no factors that will give us this negative 15. So we will then have to use the quadratic formula, minus b plus or minus square root of b squared minus 4ac over 2a. So b is negative 15, so we have minus b plus or minus the square root of negative 15 squared minus 4 times 10 all over 2 times a, which is 4. When this is solved, we get values of x to be 0.87 and 2.88. We have our 2x values. Now it says that C is a maximum point. So we have to verify now which of these x values is a maximum. One way of doing that is via the second derivative. So I will now go and differentiate our dy dx function once more to get the second derivative to be 8x minus 15. So in this derivative, we are going to plug a value. Now that value that we plug should give us a negative, because whenever the second derivative is negative, it indicates a maximum value. And the value that can be plugged in here to get a negative is 0.87. So when we do that, we will get a negative answer. So therefore our C, which is a maximum, is 0.87. So now we can go ahead and find the area of this shaded region, which will be the integral from 0 to 0.87 of our function f of x. So here's what we have: the integral from 0 to 0.87 of our f of x function. So when we integrate, we're going to add 1 to the power to get 4 and divide by that 4. Here we add 1 to the 2 to get 3 and divide by that 3. And if we add 1 to the 1 that's already here, we get 2 and divide by that 2. So the integral is now 1 over 3x to the 4 minus 7.5. Well, 7.5 divided by 3 is 2.5, or 5 over 2 x cubed plus 10 over divided by 2 is 5x squared. So this is our integral in which we are going to plug our upper and lower limit. When the upper limit is plugged in place of the x, these are the values that we will get, and our lower limit is 0, and in any of these positions it will give us a 0 as our lower answer. Now the question said to express our answer to 3 decimal places, so I need to work this one once more. So we have 0.19 minus 1.65 plus 3.78, 58 over 25, which is, well, 2.32 exact. I'm just going to leave it right there.